Alright, today we're moving outside the circle, and we're going to be solving for line segment lengths outside the circle. And it's pretty similar to chords, the relationships involving secants. And we're going to be using lengths of chords, and this one's going to be a little bit shorter because you should be more familiar with it and the relationships involving all that stuff. Alright, so say we have a secant like this, moving through a line, or a circle, excuse me, and then we have another one. We'll make it orange, I guess, and it'll be like this one, I suppose. Make it like, yeah, I'll make it like this, why not? Okay, those are our two secants, and they intercept right here and make, erase this extra stuff, and they make you know, this angle out here, but we're not worried about the angle, we're talking about line segment lengths. So they intercept these points at, for the blue, we'll call it point B and point L. And for the orange, we'll call it point R and point G. R and point G. And then we'll call the end point here where they both share. We'll call that point, I don't know, P. How about that? How about point P? Okay, so those are the different line segments made up by the secant and where they intersect the circle. Okay. Well, they also make up an entire line. For point blue, the entire line segment length we're gonna call point BE. Actually, that'd be point BP, I suppose. That'd be point BP. Point BP, and the entire orange length would be point RP. Point RP. Okay, so the relationship which exists here is very similar to the relationship of the two chords that intersect, but slightly different to make it confusing. Okay, so the relationship that exists is that the entirety of the line segment length, BP, times just the stuff that's outside, so this would be LP, times LP, P's red, times LP of one line will be equal to, that's the product, remember, will be equal to the product of the same thing on the other side. So we got RP, RP of, that's the whole line segment of that side, and RP, and it would be CP over here, CP right here, CP right here. All right, so that is the relationship that for a secant at two secants that intersect outside of a circle. I mean, that's where they would intersect, otherwise they would be chords, right? So let's walk through an example right here. Okay. All right, so here is our question. Our question is, we have two secants that are shown. We have PM is a long one and CM, other long one, and they intersect at point M. PD, I'm gonna make these bigger. All right, so we have orange secant, and we have our blue secant. So orange is PM, and blue secant is CM. All right, And we know that, let's go ahead and this is step 2 of our 5-step process. All right, step 2 is to transcribe the givens onto the drawing. Right, so we're going to take our PD, which is an orange value. PD is X. And C and DM is 3. Okay, and CK is 8, and KM is 4. And we got to find the secant length of CM. Okay, well that's the first question, is what is the length of CM? Well, that's pretty simple. You know, CM equals the line segment addition says CM equals CK plus CM. CK plus CM equals 8 plus 4 equals 8 plus 4 equals 12. All right, so now I've got to find the value of X, which is a little bit more difficult. So step 2 is write an algebraic, figure out what a situation we're in and write an algebraic expression in terms of the circle to kind of make it as simple as possible, right? So we are in our algebraic relationship here, where the entire length of the secant that enters the circle, and then until it intersects with the point of intersect with the other secant times the line segment outside equals the same thing for the other secant. So let's put that in terms of what we have in front of us here. All right, so it's going to be our long line of orange, PM, right, times the outside, PD, or sorry, MD, or DM, whatever you want to say, neutral color equals long line CM times KM. That's KM. All right, so now I'm going to evaluate what I'm given and see what I want to do with my algebraic manipulation. It looks like I only have one value. PM is going to be X plus DM, right? Because PM is not really given to me, but PM equals PD plus DM, which equals X plus 3. So I'm going to substitute that for PM. So that's going to be my PM value, and that's the only thing that is a variable. So I'm going to make DM, I'm going to move that over here, and then I'm just going to distribute from that. So I'm going to rewrite my equation as PM equals CM, and KM divided by DM. And then I'm going to distribute. So PM equals X plus 3, which is going to be equal to, that should be a neutral color. This should be a neutral color. Equals, and then my CM I've already identified as 12. That was done up here. All right, so my CM equals 12 divided by, and then my DM is 3. Oh, sorry. See, I haven't completed it. Oh, no, I did. Yeah, CM times KM, which is 4, divided by DM, which was 3. So I'll carry this up here. So X plus 3 equals x plus 3 equals 12 times 4. Oops. 12 times 4. Wow, it's like 48. 12 times, what is going on? 12 times 4 equals 48 is still 48. 48 divided by 3. I'm going to do that all in one step. Divided by 3 equals 16. So I'm going to turn this into a different color. 16, that's 2 sides. Okay, so then all I'm left with is this over here. So I'm going to bring the 16, the 3 over there, subtracting 3 from both sides, so x equals 13. Okay, so that's how that whole thing works there. Okay, so hopefully that makes sense to everybody. If you have any questions, let me know.